Hi, my name is Dimitri, and in this screencast I want to show you some of the ways in which ReSharper supports C++ development. Let's take a look at some of the ways that ReSharper helps C++ developers navigate around their code. So I'm going to open up a header file here. And obviously I want to make sense of this header file, and to help me do this, ReSharper provides a file structure window. Now this window provides a very well organized layout of the actual contents of the file. So for example, here I have a section with include statements. I have some forward declarations here. I have a top level enum here, and then of course I have several classes that I can actually go to. Now the file structure window can actually be synchronized with the editor both ways, so as you change the selection in one of the locations, the other selection gets updated as well. So let's take a look at the function called getMass. Now, if we look at it, we'll see a small icon here on the left, and this indicates that there is a definition for this declaration in another file, and you can go to that definition either by pressing F12 or by simply clicking the icon. And to get back, you do exactly the same thing, so we can press F12 here. Now let's suppose I want to find out where exactly getMass is being used. I can search for usages by pressing Shift F12, and ReSharper finds 5 usages for me. So here it tells me exactly where the file resides and what the line is. And on the right, I can also see a preview of the function being used in the context of the whole file. And as you can imagine, as soon as I double click the exact find usage element, I get taken to the exact location in the file. Now, when it comes to searching by name, ReSharper actually unifies its search with a single pop-up window that can search for practically everything. So files, classes, and individual symbols. So let's suppose I go off looking for a contact, and as I keep writing B2CON, for example, you can see that the list is continuously being filtered by ReSharper, only showing the things that are relevant to my search. Now here, what I can do is I can pick either a header or a CPP file, or the class itself, or one of the correspondingly named members. Now, if I want to show only symbols and not files or folders, I can press Shift or Alt-T, and this leaves only the classes, fields, and functions in the list. So let's go to B2Contact. Now I can move around this class by holding the Alt key and pressing down and up to move from one member to another. However, if I want to find a particular member in this file only, I can press Alt backspace and I can type the symbol name, such as eval, and go to the evaluate function. Now, evaluate is a pure virtual function, so let's find out the locations where it's actually implemented. To do this, I can press Ctrl F12, and I get a list of all the locations where this function actually has an implementation. Notice the icon next to the function. It basically shows us that this implements a particular method from a base class. And what we can do, in addition to clicking it, is we can press Alt-Enter, and then we get some options for actually navigating from this location. So the two options are to go back to the function that we've actually implemented, or we can simply go to the declaration in the corresponding header file. Now that we're inside Circle Contact, we can actually jump from the member declaration to the class declaration by using the Go to Containing Declaration shortcut, which is Control and left square bracket. And this takes us right up to the class name. So from Circle Contact, we can navigate up the hierarchy by pressing Control Home. And similarly, we can locate all the derived classes of B2Contact by pressing Alt-End and going to one of them. And last but not least is the Go to Related Files navigation option, and this option allows for either navigating to the corresponding header or CPP file, or also navigating to the local header files that are included in the current file. And the way we can bring this up is we can press Ctrl Alt 7, or I can press Alt back quote to actually bring up the full navigate to menu, which contains every option for navigation, and I can simply go to the corresponding element. And we get a list of both the declaration definition mapping. Since we're in the header file, we get the CPP file, but we also get a link to the included file B2Contact, and we can navigate to that as well. ReSharper comes with a lot of functionality for actually checking your code and performing various fixes and refactoring. So let's take a look at some of them. And I'm going to start from scratch here. I'm going to make a class called person, and we're going to be putting some fields into that person. So for example, let's suppose that I want to give a person a name. So I write string name, but the problem is string exists in the namespace std. So I get this blue pop-up from ReSharper telling me that I can fix this. And if I press Alt Enter, I get the std prefix in front of the string type. So now I want to determine whether this person can actually vote or not. So I'll have a function which returns a boolean, and I'm going to call it can vote. And I'm going to return a value indicating whether the age is greater than or equal to 16. Now the problem is age hasn't been declared yet, so we need to make it somehow. And ReSharper provides a create from usage mechanic. So here I can press Alt Enter, and I have a couple of options for how I can actually create age. So I can certainly make it a global or a local variable, but in this case I need a field. So as you can see, ReSharper correctly infers that the field is of type int. And I probably also want to initialize the field from the constructor. So one way to do this would be to write the constructor manually and simply pass the age in here and then press Alt Enter to initialize the field from the argument. Of course, an entirely alternative mechanism is pressing Alt Insert, which is the generate menu, choosing constructor, specifying that I want to initialize age, and pressing finish, which gets us pretty much the same result. Now, one thing worth mentioning is here in the binary comparison, I can flip the operands. I can press Alt Enter and actually swap the locations of age and 16. So now I get 16 less than or equal to age. It does exactly the same thing, just things swapped around. All right, now let's suppose I don't want to calculate the voter status on every single invocation. Instead, I want to do this once in the constructor. Well, how would I do it? Well, essentially what I can do is I can make an enum with a couple of fields. So let's make an enum, and we'll have states of minor as well as voter, and I'll call this status. Now what I can do in the canVote function is I can actually switch on that status and check which value I get. So I can switch on status. And here I can press Alt Enter and actually generate the missing case statements. This generates every single possibility out of the enum that we're trying to check. So in this case, for minor, that would be a false. And for every other value, this would be true. But of course, we need to initialize the status. And let's make it more complicated by adding another field. We're going to have a Boolean field indicating whether somebody is a resident. So essentially you can vote if you're of a proper age and you're a resident. So if age greater than equal to 16, and you also have to be a resident, and then you can vote. So then your status becomes voter, like so. All right, but I can fold those two ifs together. So I can move here and I can first of all remove braces, which gets rid of the braces around the ifs because then it's needed. But I can also merge the two nested if statements. Finally, let's take a look at the refactoring. Let's suppose I want to rename age to legal age. What I can do is I can press Ctrl-Shift-R to bring the refactor this menu. I can choose rename and type legal. And notice ReSharper is offering legal_age down below, so I'll choose exactly that. Press return and notice the renaming is done. Now let's take a look at something different. Let's take a look at the macro support in ReSharper. So essentially here I have two macros. I have a multiply macro that multiplies two values, and I have a multiply and add macro that leverages the multiply macro. And if I navigate to the actual location where that macro, the top level macro, is being used, I can press Alt Enter and I have a couple of options for how to substitute the call. So I can substitute just a one level call, which means a mad gets turned into a multiply plus z like so, or alternatively I can recursively inline every single macro definition. So here, if I substitute all the nested calls, I get the final substitution. Code analysis is a key feature of ReSharper. Essentially, as soon as you open up a solution, ReSharper begins to continuously analyze your code and find errors and inaccuracies and tell you about them. So here, for example, we have quite a few problems. First of all, we're using symbols like cout and endline, which are part of the std namespace, but we haven't included the namespace prefix. So as we move the cursor over, ReSharper has a blue pop-up telling us that this is part of the std namespace. I can simply press Alt Enter a couple of times and those problems are fixed. Now we have a problem that we're using the variable from a parameter that's being captured by a lambda, but not inside the capture list. So we need to do something about that as well. Let's put an equal sign here. And of course, now that we've made this function, we might want to assign it to a variable. So what we can do is bring up the refactoring menu and choose introduce variable. And this simply gives it a name like x, for example. Here we have another problem. We're using a variable that might not have been initialized. And what we can do once again is we can press Alt Enter and we can initialize the variable with a suitable default value. Here we have a function which doesn't have an actual implementation, so let's press Alt Enter once again, and here we actually have two options. The first option is to generate the implementation of a function outside the class, and the second option is to generate an inline implementation. So let's add the result here. Now here we have a more tricky problem. We have a function which uses an if statement but then puts a possibly erroneous semicolon right after it, resulting in the return being called at any input value. So as you can see, ReSharper tells us that this is a possibly erroneous empty statement, and also we can see that down below we have some unreachable code. So that's a sign that something is probably wrong, and we can simply get rid of the semicolon here. And this fixes some of the problems, but now we have another problem in that not all control paths in this function actually return a value, so we need to add something to the else statement. Now let's take a look at this example here. We have a function which takes an enum and it switches on just about every case of the enum, but it forgets certain cases, and the problem is that we have once again an incomplete function because some of the input values do not actually return anything as a result. So we can once again move here, press Alt Enter, and actually generate the missing statements. So the statements where something has to be returned at any rate. And let's just do the default here like so. So this fixes the problem with the return values, except for the started one, that should be a 2 as well. And that's just some of the ways that ReSharper helps you detect errors and automatically fix them. Thanks for checking out the screencast. Hopefully I've been able to demonstrate some of the ways in which ReSharper supports C++ development. Now, to find out more, you can download an early access preview version of ReSharper by going to the link below. And thanks for watching.